This is grade 12 mathematics Ethiopian University entrance examination in English part 14, presented to you by Umar Adam. Now, in our last video, we have solved a number of questions related to calculus and regarding the entrance examination, those that already appeared on the entrance examination and those that are actually speculated to be appear on the coming entrance examination. Now, today we will begin from where we stopped last time. Here is our today's first question. Question number 27. It says, let f of x is equal to 6x over x plus a. For what value of a is f prime of a is equal to 1? That is what the question says. Now here, what are given? F of x is given as such, and what is required? F a is required, given that f prime of a is equal to 1. And therefore, now let us begin. The first thing we have to do is we have to derivate f of x is equal to 6x over x plus a. Remember, we say if two functions are written as a fraction here, if two functions are given as a quotient, which means f over g is given, both are with respect to x. I'm not going to write x here. Suppose if this is given, then the derivative of f over g is equal to, first derivate f and then multiply with g. That means f prime of x multiplied by g, and then subtract this thing again, minus, again multiply f by the derivative of g of x, which means f multiplied by g prime of x over square now the denominator, which is g square. This is known as the quotient rule of derivative. That was what we have seen. Now, let us begin with this one. Here, as a numerator, we have 6x, and the denominator of f of x is x plus a. First, derivate the numerator, which is 6x. 6x, the derivative of 6x is simply 6. Then multiply the result with the denominator, which is x plus a. Then minus, again, here multiply 6x by the derivative of this denominator, x plus a. When we derivate x plus a, it becomes a is constant, therefore a becomes 0. The derivative of x is 1. 1 times 6x gives us 6x. Over, by the quotient rule of derivative, x plus a square. Therefore, f prime of x is equal to 6 times x plus a, then minus 6x over x plus a the whole square. But f prime of a is equal to 1. It is already given. And therefore, replace x by a. Here, when we replace x by a, it becomes 6a plus a minus, here again, minus 6a over, here replace x by a plus a the whole square. Then this result is equal to 1. Now, here a plus a is 2a. 2a multiplied by 6, it is 12a. Minus, here we have 6a. And again, the denominator is a plus a the whole square, which becomes 2a the whole square. And then 2a the whole square means 4a square. Multiply 4a square by 1, it becomes 12a minus 6a is equal to 4a square. And then 12a minus 6a becomes 6a. 6a is equal to 4a square. Then move this expression into one side, which means it becomes, now when we move 6a to the right, it becomes minus 6a. Therefore, 4a squared minus 6a is equal to 0. Then common out 2a from this expression. If we common out 2a, then what is left here? It is 2a minus, here we have 3 only, because when 2a is multiplied by 2a, it becomes 4a squared. And again, when 2a is multiplied by minus 3a, it becomes minus 6a. Sorry. This result is equal to 0. Now, for any question, for any equation in the form x times y is equal to 0, either x is equal to 0 or y is equal to 0 or both. And therefore, either 2a is equal to 0 or 2a minus 3 is equal to 0. But our a cannot be 0, because if a is 0, then f prime cannot be defined, since the denominator becomes 0. There is no number which is divided by 0 and it gives us a number, a real number or complex number or whatever it is. Therefore, a must be restricted as a cannot be 0, and therefore 2a minus 3 is equal to 0. Then solve this linear equation. It becomes, move 3 to the right, it becomes 3 over 2. Our a is equal to 3 over 2. That is the value of a. When a is equal to 3 over 2, then the derivative of this function at a gives us 1. Now, your answer should be C, the one in C. Let us see the next question. Question number 28. It says, if g of x is equal to f of x over x plus 1 plus f of x the whole square, comma, f of 1 is equal to 8, it is given, and f prime of 1 is also equal to 2, then the question says, what is g prime of 1? Now here, we are given, given g of x is equal to f of x, this is given, and also f of 1 is equal to 8, and f prime of 1 is equal to 2. These are given. What is required? Now here g prime of 1 is going to be calculated from this one. It can be obtained from this one. The first thing, we start with the original function. G of x is equal to f of x over x plus 1 plus f of x the whole square. Here, derive this function. Derive both sides of this function. It becomes g prime of x is equal to, now here, as you can see, this is fraction, then apply the quotient rule here, and also to the derivative f of x the whole square, apply the chain rule. The chain rule here, f of x over x plus 1 becomes the derivative of this one, is first derivative f of x, and then multiply the result by x plus 1, and then minus, again, multiply f of x by the derivative of x plus 1, which is here, f of x minus times x plus 1 derivative, over, then square this one, square the denominator, which is x plus 1 the whole square, and also plus, here this part again, the derivative of this part, first derive the power, 2 times f of x as it is, then by chain rule, the derivative of f of x again becomes f prime of x. And now, here this derivative becomes, therefore, g prime of x is equal to f prime of x multiplied by x plus 1 minus f of x. The derivative of x plus 1 means it is 1 times f of x over x plus 1 the whole square, plus this expression, 2 times f of x, f prime of x. And then replace x by 1, g prime of 1. That is what we are going to find. G prime of 1 is what is required, and therefore g prime of 1 is equal to f prime of 1. Here we have f prime of x, therefore replace x by 1. Here we have x plus 1, replace x by 1, it becomes 1 plus 1, minus, here we have f of x, then replace x by 1, which it becomes minus f of x, f of 1, over again, here we have x plus 1 the whole square, then when we replace x by 1, it becomes 1 plus 1 the whole square, plus 2 times, here f of x, f prime of x is given, then therefore 2 f of 1 times f prime of 1. Here, since our f of 1, which is given, is equal to 8, and f prime of 1 is also equal to 2, then we have 2 times 2, 2, f prime of 1 is 2, and 1 plus 1 is also 2, 2 times 2, minus f of 1 is 8, as you can see here, over here 1 plus 1 the whole square means it is 2 square, plus f of 1, it is given here, it is 8, 2 times 8 times f prime of 1 is also equal to 2, 2 times 8 times 2 means it is 32, it is 32, and then here we have 4 minus 8, it is minus 4 over 4, 2 square is 4, minus 4 over 4 becomes minus 1 plus 32, it becomes 31. Therefore, g prime of 1 is exactly equal to 31. That is the solution for this particular example. Therefore, our choice here is B. The right answer is the one indicated in B, in choice B. Now let us see the next question. Here, this question is related to rate of change of function. It says, question number 29 says, a point moves along the curve y is equal to x cubed minus 3x plus 5, so that x is equal to 1 over 2 radical t plus 3, where t is time. At what rate is y changing when t is equal to 4 units? It can be for minutes or for seconds or for hour, whatever it is. Anyway, now here there is no unit here. Our t is 4 units. Let us see. Let us see how to find the change in y. When y is moving, when that point, a certain coordinate x and the y is moving along this curve, the curve which is given by x cubed minus 3x plus 5, then how, with what rate or how fast is y with respect to time? That is what the question says. Now here, what are given? The curve is given, y is equal to x cubed minus 3x plus 5 is given, and also x is equal to 1 over 2 radical t plus 3 is given, where t is time. Sorry, there are some noises around me here. Now here, t is equal to 4 is also given, 4 unit is given. Now as you can see, y is dependent on x, and x is also dependent on t. Therefore, indirectly, y is also dependent on time. And what is required? It is dy by dt when t is equal to 4 is required. Therefore, we are going to find dy by dt, the rate of change of y with respect to time. Then, first derivate y is equal to x cubed minus 3x plus 5 with respect to time. Derivate y with respect to time, even though there is no time here, since our x is also dependent on time, since x is given as a function of time, and therefore dy by dt becomes, derivate this one, x cubed means 3x squared multiplied by dx by dt, since x is dependent on time, dx by dt, and then minus, again derivate 3x, here 3x becomes 3, but multiplied, our x is dependent on time, multiplied by dx by dt, and the constant, the derivative of 5 with respect to t is 0, since it is constant, and then common out dx by dt from this expression. It becomes 3x squared minus 3 d multiplied by dx by dt. And also, what is dx by dt? Dx by dt means derivate this expression with respect to time. And then it becomes dx by dt is equal to, here we have 1 over 2, which exists originally here. And then the derivative of radical t becomes 1 over 2 times radical t. And then 1 over 2 times 1 over 2 radical t means it is 1 over 4 radical t. This is the rate of change of x with respect to time, while the rate of y with respect to time becomes 3x squared minus 3 multiplied by dx by dt. And then here, first find the value of x when t is equal to 4. X of 4 means it is equal to 1 over 2, the square root of t, then replace t by 4, plus 3 here. 4 is a perfect square, and therefore 2 will come out from this square root. 2 times 1 over 2 becomes 1. 1 plus 3 is equal to 4. Therefore, our x is equal to 4. And also, dx by dt is equal to 1 over 4 times, here replace this t by 4, 4 times radical 4. 4 times radical 4 means it is simply 8, because radical 4 is 2. 2 times 4 becomes 8, 1 over 8. Now the rate of change of dx with respect to time is 1 over 8. And then dy by dt becomes, here replace x by 4, because we already obtained the value of x when t is equal to 4, which is equal to 4. And then 3 times, replace this x by 4, 4 squared minus 3, and again dx by dt is equal to 1 over 8 multiplied by 1 over 8, this expression. 4 squared is 16, 16 times 3 is 48, 48 minus 3 becomes 45, multiply 45 by 1 over 8, it becomes 45 over 8. Now, y is changing at this rate, at 45 over 8 per unit of time, while x is changing as a rate of 1 over 8 per unit time. Therefore, now we are not asked this one, dx by dt, but we are asked the rate of change of y with respect to time, which becomes here, it is solved 45 over 8. Therefore, our answer in this case is the one indicated in multiple choice A. That is 45 over 8. Now let us move to the next question. The next question is going to be the last question for today's video, or for today's lesson, and therefore let us deal with this one. Here it says, for what value of k will f of x is equal to x minus k over x have a relative maximum value at x is equal to minus 2. I told you before, relative maximum or relative minimum can be found at the critical number, and therefore what we have to do is we have to derivate this function and then equate the resulting of the derivative with 0. That means here f prime of x, the critical number is obtained at f prime of x is equal to 0. That means the critical number can be obtained where either the derivative of the function is equal to 0 or the derivative of the function does not exist. Therefore, here this must be equal, this one is 0, then derivate this function. The derivative of f of x is equal to x minus k over x becomes here 1 plus k over x squared, because k over x, when it is derivated, it becomes minus k over x squared minus k over x squared multiplied by minus 1 becomes plus kx square. Then 1 plus kx square is equal to 0. And again, our critical number x is equal to minus 2. Therefore, replace x by this value, minus 2. It becomes 1 plus k over minus 2 square means it is 4. Therefore, solve this linear equation. It is linear equation, and therefore we can solve as such. K over 4 is equal to, move this one to the right, it becomes minus 1, and then multiply 4 by minus 1. Therefore, k is equal to minus 4. When the value of k is equal to minus 4, then this function f of x has a relative maximum at x is equal to minus 2. If and only if k is equal to minus 4. Therefore, the required variable is obtained. It is minus 4. That was what we have been asked. And minus 4 is here in choice C. If you answer this C, then you get the point, or you will get the point. Now, this is the end. If you actually like this video, please don't hesitate to like, to subscribe, and to share to others, so that people like you, learners like you, who love mathematics, can understand better how to solve questions that are related to calculus. Have a good time. See you in our next video. Bye.